Welcome to my presentation. This is a continuation of application example 2. This is part 2. We are continuing from part 1. If you watch the previous video, you will see part 1 of this particular example. So this is where we left off, and we will continue from this point on. Where we left off in the part 1 was at this point. 1, 1.75, 12.25, and then the second row was 0, 1, and 3. This is where we left it, and therefore to be able to write a system of linear equations from this final augmented matrix, we can write it as follows: x plus 1.75 is equal to 12.25. That is our equation number 1, and then x plus 1.75 y is equal to 12.25, and then the second equation is y equals to 3. This is our second equation, and then we have a solution here. Y is equal to one part of the solution is y equals to 3. We can substitute the value of y into the equation number 1. We can back substitute and then find the value of x. So x plus 1.75 times 3 is equal to 12.25. So x plus 1.75 times 3 is going to be equal to 5.25, which is equal to 12.25. We want to find the value of x, so therefore x is equal to 12.25 minus 5.25. We are using the addition property to be able to simplify this. Therefore, when we simplify this, 12.25 minus 5.25 is going to be equal to 7.0. So therefore the value of x is 7.0 and the value of y is 3. Therefore the solution here is x equals to 7 and y equals to 3. And what does this indicate to us? This is indicating to us that let me write this one more time. The solution here is x equals to 7 and y equals to 3. This means the value of the adult ticket is $7. Value of adult ticket is equal to $7, and the value of children's ticket is equal to $3. That is how we should be able to tie it back into the given problem. Now we can use this information to check our work. Let us say if we want to check whether this satisfies the original equation given to us. We have formulated the original equation as follows. The first equation we have formulated was 100x plus 175y is equal to 1225. That is, we sold 100 tickets, 100 adult tickets and 175 children's tickets, and the total collection for the first day was $1,225. And if one adult ticket costs $7 and the children's ticket costs $3, will that satisfy this equation? Let us see. We'll check that. So 100 times 7 plus 175 times 3, that should equal to 1225. 100 times 7 is 700 plus 175 times 3 plus 175 times 3 is 525, and that should equal to 1225. So 700 plus 525 is in fact 1225. That is exactly equal to the value what we have on the right hand side. Therefore the value on the left hand side is exactly equal to the value on the right hand side, and therefore the values of x and y are exactly correct. We can also apply it to check the second equation and see if that satisfies it or not. So the second equation we have is as follows: 200x plus 316y is equal to 2348. That's what we have. That is, on the second day we sold 200 adult tickets, and then we sold 316 children's tickets, and the total collection we obtained was $2,348. So if we were to substitute the values of x and y, or the values of adult ticket as $7 and the value of children's ticket as $3 into this equation, will we be able to get $2,348? We'll see. So 200 times 7 plus 316 times 3, that should equal to 2348. So 200 times 7 is 1400 plus 316 times 3, that is going to be equal to 948, and that should equal to 2348. And when we add these two numbers together, we get 2348. That's equal to the value what we have on the right hand side. Therefore the value which we have on the left hand side is exactly equal to the value what we have on the right hand side, and therefore the values what we've obtained for x and y are exactly correct. The value of x is the value of the adult ticket, and the value of y is the value of children's ticket. And this is the way we want to be able to solve application problems using system of linear equations and using matrices to solve these system of linear equations. In my next presentation, we shall look at some more examples related to solving system of linear equations using matrices, and this time with applications.